Hello everyone, this is lecture number 52. We are going to start one topic, that is torsion. If torsion is induced in the beam, how will tackle this torsion problem? So according to code, there is some provision given for the moments and shear. That is, you have to increase the moment. The moment will be replaced by equivalent moment, where the combination of your bending moment and torsion will come up. And in the shear, also your regular shear force and the equivalent shear force will come in the figure. So now let us start the provision of code if the torsion is provided in the beam. So we go look at the point, page number 86. This is torsion provision is given in page number 86, IS 456/2000. Let us clear it, make it clear to all of you that this torsion is need not to calculate, but due to stiffness of the member, some torsion is induced. That amount of torsion will be given to you, and you have to calculate the equivalent moment, equivalent shear, and you have to provide the provisions as given by the code. So let us start one by one. So what is the actual torsion? We can say that is for shear, you can calculate the shear torsion, that is BU. BE, you can say this is a BU plus 1.6 P by B. This is the equivalent shear force. This is equivalent shear force. BE is equivalent shear force, where VE equals to equivalent shear force, in which the contribution of torsion is given by this formula 1.6 T by B. This will be additions. So what will you do, that you must find out this value for the given torsion. BU you already know, so you can calculate this value. So you can find out BE divided by BD. This value should not be greater than, should be less than tau C max. Tau C max. If suppose the condition may arise that the equivalent nominal shear force tau B in this case shall be calculated the BU by D. If the equivalent nominal shear set tau B does not exceed tau C, if this is one case. Second, if your tau C, this tau, you can say tau BE is less than your tau C, you need to provide nominal shear force. Provide nominal shear. This step. If this is like this. Case third, if tau B exceeds tau C, is tau B is greater than tau C, what will you do? Both longitudinal and transfer resistance shall be provided. Both, if this is like this, both longitudinal and transverse reinforcement will be provided एज बिलो क्लास के हिसाब से। कहने का मतलब ये हुआ कि फॉर इस लेक्चर्स में हम ये बताना चाह रहे हैं कि इफ टॉर्सन इज इंड्यूस्ड, टॉर्सन अगर इंड्यूस कर दिया जाएगा तो क्या होगा, मोमेंट, इक्विवेलेंट मोमेंट बदल जाएगा और साथ ही साथ शियर में भी कंट्रीब्यूशन बदल जाएगा। तो कोड ने प्रोविजन किया है इसके लिए जनरली टॉर्शन प्रोड्यूस होने में स्टील की मात्रा कंप्रेशन जोन में जनरली हमको बढ़ाना पड़ेगा और साथ ही शियर की जो स्पेसिंग है उस पर भी काम करना पड़ेगा। तो दो तरह की चीज़ों पे काम करना पड़ेगा और इसके लिए जैसे आपने V इक्विवेलेंट हमने VU प्लस 1.6 टी बाई लिखा है, इसमें 3 केसेस, पहले आप ये चेक कर लो V बाई BD इज लेस देन टाउ सी मैक्स, ओके है। अगर आपकी टाउ B इज लेस देन टाउ सी तो नॉमिनल आप प्रोवाइड कर देंगे, ठीक है। अगर ये टाउ B इज ग्रेटर देन टाउ सी है तो लॉन्गिट्यूडनल और ट्रांसफर रिइंफोर्स दोनों को आपको चेंज करने की आवश्यकता पड़ेगी। टाउ B इज ग्रेटर देन टाउ सी है इस कंडीशंस में। अगर ये टाउ B इज ग्रेटर देन टाउ सी मैक्स हो जाएगा तो आपको सेक्शन को रिवाइज करना पड़ेगा, सेक्शन को बढ़ाना पड़ेगा। तो फोर्थ केस कैन बी फोर्थ इफ योर टाउ B इज ग्रेटर देन टाउ सी मैक्स, redesign the section. So torsion is additional moment or additional shear to be provided in the beam in the form of compression steel, in the opposite that is a bending के, जैसे आप बेंडिंग में आप बेंडिंग मोमेंट के लिए प्रोवाइड कर देते हैं, that is you are providing for the hogging, that is sagging moment, you have to provide in the compression zone extra. So we'll discuss one by one. So let us see how these two be provided when tau B is greater than tau C. When tau B is greater than tau C. So if that is longitudinal reinforcement, पहला आएगा longitudinal reinforcement। if your tau BE is greater than tau C, tau B is greater than tau C, so we have to, that is what the longitudinal reinforcement will be provided. The longitudinal should be designed with the equivalent bending moment, that is M, this will be ME1 equals to your MU plus MT. M is the bending moment due to cross section, MU is bending moment due to cross section, and MT equals to bending moment due to torsion. This will be your T1 plus D by B divided by 1.7. This is increase in some percentage. This 1.1 plus D by B divided by 1.7. This is some factor. This can be alpha into T. So there is an increase in the T that is equal to your MT. Whatever is the torsional moment, that will be treated as MT. So your MU plus MT is there. According to this, the longitudinal reinforcement will be calculated. Now in this case, if it happens that your MT is greater than MU, suppose, in this case, the difference of MT minus MU will be provided in compression zone, in compression steel. This difference, इस difference की वजह से जो मोमेंट आएगा, MT माइनस MU के इक्विवेलेंट मोमेंट की वजह से जो स्टील की मात्रा आएगी, that will be provided in the compression zone. Suppose this is your beam. This is your beam. You are providing the moment here, the quantity of steel here. This is provided due to ME1. Now here you are providing two hanging anchor bar. These anchor bars will be increased if MT is greater than MU. So difference of MT minus MU will be provided, the AS2 over here. So the AST2 will be there if MT is greater than MU. But in design we see if this is not MT and MU is not related, that is MT is not greater than MU, even then in designer can provide is per MT. This MT can be MT or this is torsion moment, MT can be provided over here. They have adopted for the safety point of view. There is some consideration. The designer may provide. They are providing this MT over here. So we'll in the example we'll discuss this thing. So if it happens, यदि होता है equivalent MU1 MU plus MT, if MT is greater than MU, then the difference of this will be provided in the compression zone. Opposite to this, they will be provided. This is written in this code. If the numerical value of MT as defined exceeds the numerical value of moment M, longitudinal reinforcement shall be provided on the flexure compression phase such that the beam can also withstand equivalent moment ME2 given by ME2 is equal to, this will be given by ME2. This is your MT minus MU equal to your ME2. This will be provided in compression zone. So this is to be taken care of. तो इसका आप care करेंगे. So now let's discuss some other point. This is the provision of the longitudinal reinforcement which will provide in the tension zone as well in compression zone. So if MT, that is this is clear, one point, if MT is greater than MU, the difference MT minus MU will be provided by ME2 in compression zone. Yeah, likely or designer provide even MT in compression zone. ठीक है, MT equivalent they are providing. This is, and this ME1 equals to MU plus MT. This will be provided in tension zone. This will lead for the effective depth of the beam. Beam के effective depth भी हम लोग इसी से consider करेंगे. So now this for the moment point of view, this is clear that you will go for the ME1, and in the same way you can calculate these MU and MT. If MT is greater than MU, then this is the provision, and even then if it is not like that, then designer provides MT in the compression zone. That we will discuss in the problem. So ME equivalent is one item, ME2 is the second item. So we provide the longitudinal reinforcement according code in this way. Now we'll go for the transfer reinforcement. How the transfer reinforcement will be provided. Let us see the transfer reinforcement which will be provided. Now the code says the transverse reinforcement. According to code, that is too late closed stirrups. Too late closed hoop. In closing the corner long bars have an area of cross section ASB given by, means if this is a beam, आपका beam है ये, suppose करो, this is your beam, or we are providing some bar over here, maybe 3 or 4, whatever it may be, and at least we are providing 2 bars over here, and this is covered by a leg. This is 2-legged stirrup. This is saying closed. This is saying the closed. The 2-legged closed hoops in closing corner long parts shall have an area that is ASB. इसका एरिया ये 2-legged है. This is 2-legged. 2-legged स्ट्रप है. ये क्लोज है, ओपन नहीं है, क्लोज है. तो इसका ASB will be given by your T, and this you have T into SB divided by B1 D1 into 0.87 FY plus B, that is your B into SB divided by 2.5 D1 0.87 FY. This is your value. You gave it by that. This is your, but total in stirrup, this is value. But total, that is total transfer reinforced shall not be less than total transverse reinforcement shall not be less than what value? That is your ASB should not be less than tau B minus tau C divided by your 0.87 FY multiply by B into SB. You can say SB, something like that. That your ASB should not be less than this value. You check this thing, ASB will be gone like this. So you can find out the ASB from this spacing, and now put this spacing over here and check the ASB, which should not be less than this value. Yeah, you find out the ASB from here, you put the ASB and find out the ASB, whatever value of ASB is coming, you should provide not less than this thing. So for this is all about this thing, and that is given in the code. And now one more thing is there which we will discuss over here. What is your B1, D1 and something like that. Let us discuss in this figure. Let us clear this thing. This is your ASB should not be less than this value, 2-legged. Now what is this is your B, this is your B, right, and this is your D, this is your D. And what is B1? This center line of outer bar, that is B1 and B1, this is your B1, and for center line this top bar to the extreme, this is your D1. This is your D1. So what is the B1? B1 is center to center, center to center, center to center to center, center to center distance between extreme bar in direction of B. And similarly, D1 is the center to center, center distance between extreme bar in direction of D. So this is your B1. You suppose this is your B1. B1 means that is B minus 2 side covers minus pi by 2 minus pi by 2. This is pi by 2. This is your B1. And what is D1? D1 equals to B minus top cover, this is top cover, minus pi by 2. This is your D1. This is your D1. D1 is equal to D minus cover top minus pi by 2. So you can always find out this value. So you find out ASB with this formula and check according to this which is provided or not. Now how the shear reinforcement will be provided, that is the spacing is given like this, but for the torsion we take care of this shear, that is we, if suppose this is your beam, so which is x1 and x2, this is B1, so let us find out the some other value in this way. We have some other value y1, x1 y1. We have some value. The spacing will be provided. So let us discuss. Let us discuss the problem. Suppose this is your stirrup, which is provided. This is your stirrup. So more bars may be there. So this is your stirrup, this is your cover, this is your cover, maybe cover like this, cover. So here this value, that is extreme of your stirrup, this is your x1, and the stream of stuff in D direction, this is your y1. This is your V, this is your total B, and this is over RD. Your RD. So here we are looking for this is your stirrup. So the outer of stirrup to outer of this stirrup is x1, and this outer of this stirrup to top stirrup, this is y1. So what will be the spacing of the stirrup? Will be minimum of these. Number 1 x1, number 2 x1 plus y1 by 4, and number 3 300 mm, 300 mm. This is the provision for the torsion, that the spacing of stirrup, although we have calculated this stirrup, but we check this spacing, that is, this should not be greater than the least of the will be taken. And one point, if the width, this V, the cross sectional area, cross section dimension is greater than 450 mm, if greater than 450 mm, the wave reinforcement on both sides 0.1% of B into D will be provided. That is 50% on both ways, on both face, vertical face will be, on both vertical face will be provided. That is one on both face, that is 0.5 into 0.1% of BD. It is this in this direction, and similarly in this direction will be provided. This is your anchor bar, so equal this is your, suppose some bars is there, so here you have to provide some reinforcement for if the dimension is more than 450 mm. That will be taken. If this condition arises, the cross section is greater than 450 mm, then this provision will be done in the, we have to provide. If the cross section dimension 450 mm, additional reinforcement along two faces, one face and two faces, excluding these bars, faces not less than 0.1% wave area, and at rate of 300 mm R, at a rate of this value will be at a rate of 300 mm R wave dimension, whichever is less. So in this direction, in the phase direction, if it exceeds any dimension, whether depth or width increases by 450 mm, then extra 0.1%, that is half this side, 0.1% का half this side, half this side, it is spacing of 300 f, और the इस वेव का जो width है उनमें से जो कम है उसकी spacing पे provide किया जाएगा, so that the spacing of these 4 bars should be same. इस तरह से आप provide करेंगे. This is all to be done in the torsion. So this is a distribution spacing shall not exceed the least x1. ये हमने discuss किया था. x1, this is your x1, this is your y1. This is outer of this stirrup to outer of this stirrup vertically, and horizontally outer of this stirrup to outer of this stirrup. This is x1, y1 by 4 and 300 mm. And this if cross section, this is another class. This any cross section increases, then the side reinforcement, wave reinforcement will be provided equally in both faces, but the should not be less than this amount in total. So 50% will be provided this way, and 50% provided will be this place, with this spacing 300 wave dimension whichever is less. So this will be done in providing provisions of the code. This is all about the torsion. We will take an example in the next class and we will try to solve the torsion problem. Thank you for attending class. Thank you very much.